So as they sit up here, I want to introduce Don Morrison, who's an old friend. I don't know where you want to sit. I think you got room to sit on there. Or you can stand here. No, I think you're full. You got to stand here. So Don Morrison is venture capital and former executive at Intel and at Cordian and Santa Cruz Operation, and he's going to introduce his team.
Good morning, and thank you, Andres. Well, we have actually a great panel of folks that represent really a wide perspective in a number of regards. One is practitioners, people that actually apply artificial intelligence and cloud computing in real-world applications, as well as technologists, all the way from the research side to product and technology side. I also think AI and cloud computing as compute engines, if you will, for the modern industrial world and consumer world is a great intersection in a lot of topics going on at the conference today. When we look around at a number of the themes, whether it be earlier this morning, smart factories, smart cities, mobility, infrastructure, all the way from energy infrastructure to water, and certainly with the climate matters going on even right now, we can see the pertinence of data, information, edge computing, artificial intelligence, and decision making being more and more critical to the environment and the world of climate issues. So a lot of intersection here with artificial intelligence and cloud. Then interesting enough, of course, I think everyone's familiar with AI gives us the possibility and the vision around intelligence and decision making and greater granularity around analysis. And the cloud, as Ali had indicated, provides that huge infrastructure today that not only is scalable but affordable for pretty much everyone to build applications. In my world, being a venture funder of early stage companies and doing it for some 10, 15 years, we saw a dramatic change with the advent of AWS in particular and other similar solutions about 10 years ago in terms of what it did to bring down the cost of building applications, whether they be mobile and consumer, all the way to enterprise. And I think now we can definitely see the benefits of that. And I think you'll hear from the panel today, the possibilities are just beginning, everything from edge computing to many of the large data sets in the public sector, infrastructure, and industry. So with that, we've kind of picked up on three themes to kind of kick it off and bring some continuity to it and allow each of our panelists to talk. The first one will be, what innovations do we see really advancing solutions? And as a team, we got really focused on not just talking about the technology, but talking about the application and the outcome. A second is to talk about some of our experiences, especially those of us that are practitioners, in terms of real-world applications of AI, large data, and cloud. Because oftentimes the vision is talked about, but real customer applications are a bit puzzling and sometimes lacking. And then for folks in the room that need to think about projects and the real operational world of ROI and budgets and outcomes, what are some of the outcomes that become more dependable with these applications and deployments that we're seeing that can be good practices for you to take back? And we have a variety of areas to look at, everything from the world of smart cities and smart infrastructure and smart factories to energy infrastructure and consumer applications. So with that, I'll first ask each of the panel members to introduce themselves, and then we'll go around the panel and talk about innovations. Professor Zhang?
Thank you for the opportunity to speak today. And I'm Zhang Zong from the Computer Science Department, and I joined the department in 2011, it was 10 years ago. So we do research in AI and cloud computing and big data analysis. So I would like to share some experiences and lessons we learned. Thank you.
Please, go ahead.
Sure. Elena Bondareva, I'm an advisor with PowerLedger. I'm Australian, but based out of San Francisco now. My expertise for the last almost 20 years has been in accelerating transformational change. It's my work and my research. And so in that, I've worked around the world, Australia, South Africa, New Zealand, by now established about 20 ventures, nonprofit and for-profit, most still going. And so my role with PowerLedger is to help accelerate the transition to clean energy markets. And I'll leave it at that.
Great. Please.
Hey guys, Tucker Jones, CEO of Lumina-Labs, offices in Lexington, Kentucky and Los Angeles. We're a partner with IBM specializing in AI and machine learning, bringing those solutions to clients. We help anything from collecting and sourcing data all the way to organizing AI models. My personal specialty is machine learning in sports, so I hope to bring a unique perspective with some real-world applications and machine learning and innovation surrounding that in the sports and entertainment world.
Great. Ali's been introduced.
I'm the guy who's standing up there.
Go ahead, Dave.
Hi, good morning. I'm Dave Albano. I'm the CEO of RestorePoint.ai. We're a data management company, data automation company, and we built a platform that it has several modules in it. It's a data exchange, it's data warehouse, data visualization, and data automation. And we use that across industry to do all kinds of things for our customers. So we'll talk about some of those.
Dave?
Morning, David Inbar, founder CEO of Digitalytics. We focus specifically on wholesale energy markets, so electricity, the dynamics of those markets, and how to get ahead of them for a whole range of participants, generators, traders, utilities, potentially industrial users as well. And I look forward to talking about how we use cloud, how we use machine learning, how that all comes together to deliver critical signals which you need to get right rather than wrong. And I have a background in data and integration and somewhat of a track record of being ahead of the market, which is not always good.
Great. Well, why don't we start with innovation and trends that we see advancing real-world applications. And David, maybe I'll start with you because we talked about some very interesting applications in your world that clearly are advancing real solutions using both cloud and AI.
Sure. I'll take a shot at a few. First thing I would say, as a startup, AWS or cloud gives us the ability to move fast and not just to scale up and down, but to try different things very quickly and move data in and out. One of the most critical things about cloud is not just the cost and flexibility, but also the visibility that you potentially get into what's going on with your compute and your data. And given what we're doing, which is getting real-time data coming in off the grid and off energy markets, and then using that to turn into models, and from there into decisions, one of the critical factors we face in the real world is what happens when there's an interruption to the stream of any one of those data elements? When does your model become unreliable? When should you stop trusting it? So trust and visibility and innovations in cloud, innovations in machine learning. Everybody talks about neural nets. By their very nature, they kind of come up with their own somewhat opaque logic about how they actually arrive at their classification or their decisions about things. And so innovations in AI visibility really make a big difference from our point of view. And that's very much cutting edge. There's a lot of academic and other work going on in that field. And the final thing I'd say is sensors. It was very interesting to see yesterday ARM talk about being able to deliver you attachable multi-sensor packages that can by themselves learn what you would call normal conditions and abnormal conditions. And that's really a very interesting example of, let's call it unsupervised learning. The real question with those is, how do you take that and translate that into a complete solution that makes use of that and delivers a signal or a dashboard or things like that? But it's interesting.
Dave Albano?
Yeah, sure. So, cloud is giving us a lot of benefits. I think it gives us speed. I think it gives us simplicity. But then on the other hand, it also offers a little bit of complexity, right? So what we find is many of our customers from a data set perspective are not in one cloud, right? So they might use, Office 365 for their email and some of those things. They're using Salesforce for, their CRM side. And so the data is dispersed all over the place. It used to be in a data center, right? Now we've got it all over multiple clouds. So there's a complexity around the cloud. And we love the speed of it, but then also when we do a proof of value, so instead of doing a proof of concept for a client, we'll do a proof of value. And typically what we'll do in a proof of value is we'll use our private cloud to scale the environment. So what happens is we load a lot of data in. If I move it into the public cloud, it gets very costly. They put a bunch of users on it, they start hammering against the data and they get a big bill. And the immediate thing they do is they start pulling back. So what we do is we put things into our private cloud to start, and then we move it to the public cloud as our customers want it, or sometimes they'll leave it in the private cloud. But connecting to the multiple clouds has been an opportunity, right, to be able to take the data, to synthesize that data. Ultimately, what we're looking for is not to have to move the data in the future, is to be able to pull up data in the cloud and then correlate it in memory without actually physically moving it. So we think that that's where it will go over the next few years.
Great. Tucker, you do some really interesting work in the sports world, and I think one of the things for people in the audience is to think about the sports world in terms of athletes, performance, and talent, and you can apply that in a lot of other areas beyond sports, and maybe share some of your experiences.
Yeah, certainly. So one thing that IBM is working on right now is improving and understanding like the mental side of sports. So they're using Watson to analyze, thousands of hours of player interviews, social media, and use that to get a better idea of the player's, mental sentiment at the time. And then they could, say, okay, this player, maybe he's toward the end of the season, we can gather information that he's not as focused toward the end of the season, or he seems less confident. And they're using AI to run these analytics, and it's very interesting. And one other major innovation with AI in sports is scouting, is scouting and evaluating players. So, to the naked eye, a quarterback coach may say, okay, this is the correct way to throw a football. But after running thousands of hours of video, through a machine learning process, the analytics may point to, okay, maybe that technique that we've been teaching since the 80s, maybe that's not actually the correct way to throw a football, and there's a more accurate way, a more mechanically sound way. So that's that's two good innovations right there that are happening in sports currently.
Ilana?
Sure. This is just innovation. We'll get to trends later, right? Or is it innovation in trends?
Innovation that are advancing solutions.
Got it. All right. Well, Power Ledger is effectively an operating model for new energy markets. It enables tracking and trading of energy, flexibility services for the grid, and environmental commodities such as RECs, etc. So it's a SaaS offering. Most customers will experience it as a white-labeled integration into their system that, if your energy retailer integrates Power Ledger, you wouldn't even know it's Power Ledger, but you would have additional capabilities. So the innovation here is using blockchain for climate action and for democratizing access to energy for consumers, for organizations, as well as the utility and the grid as well. And so that innovation and using blockchain effectively addresses the challenges with the grid. So if we just think about renewable energy resources, distributed energy resources, they're not necessarily just a solution in and of themselves. A lot of you will know that they created potentially a duck curve effect, right? So the grid can actually get overloaded with the amount of renewable energy coming in. And so Power Ledger becomes secret sauce in actually resolving that. Because grid is only as good as the marketplaces that sit behind it. And blockchain enables Power Ledger to actually spin off these marketplaces and local energy markets. So a couple of kind of examples of how that actually works is Carlton United Brewery in Australia is Asahi's largest brewery in the Southern Hemisphere. They wanted to produce a climate neutral beer, but they could not generate enough renewable capacity to do that. What Power Ledger enabled them to do is to actually source excess solar from their customers and pay them in beer. Right? So if you delivered $30 worth of solar, and blockchain, you can imagine it's instantaneous settlement, it's kind of an immutable ledger going behind this, you will get a case of beer that at the store in Australia, alcohol is expensive, you would pay about $60 for. So for the customer, they're getting free beer because they weren't going to use that solar. For Asahi, they're getting a carbon neutral beer. Not only has this been a terrific success for the customers, they've gotten about $3 million of earned media, so free media, in 3 months, nationally and internationally. So not only is it a self-funding marketing campaign, it is really fantastic for the brand. So that's one example, but the innovation there is also getting people who don't normally talk to each other to talk to each other. To do this, the energy team within Asahi does not normally or very often talk to their marketing team, does not necessarily work with the sustainability team, and does not necessarily engage with finance and accounting on a daily basis. This actually starts breaking down those silos and bringing these groups of people together. Another example that I can quickly give is the project Power Ledger has done with Silicon Valley Power. Low carbon fuel standards enable a lot of municipalities in California to actually cash in on the renewable energy that they generate, for example, to power electric vehicles. It is money on the table that most municipalities are not using because of how cumbersome it is without blockchain to do the reconciliation, the documentation. It's just a lot of back of house. We were able to automate that for them, as well as to provide the marketplace to actually sell those credits right away. And thousands of dollars a month are just going into their kitty now. Another project that I quickly want to give is actually in Thailand. I'm kind of taking you all around. And the project is called T77, and it is actually a precinct that is using price signals to enable almost a dozen buildings to trade electricity between each other. They have different profiles. Some both generate and consume, some only consume, so some are only buyers, other ones can be what we call a prosumer. And just to give you an example, 2.8 megawatt hours a day of renewable capacity is produced. That is only about 18% of the total demand. By doing this peer-to-peer trading, they're all saving on average 25% on their annual energy costs. It is still cheaper for them to trade amongst themselves, and the broader the energy load profile, the more interesting the project. School, they have a school as part of the mix. They have lots of excess on the weekends, but that's exactly when the shopping center and the apartment building needs that energy. So these are the kinds of very specific applications, and reverse action marketplace for trading PPAs, power purchase agreements, is another application of blockchain that Power Ledger offers. So if you have a PPA, you need to top it up, you can do that right online. If you need to actually on-sell what you didn't use, again, you can do that. And we'll talk about it kind of trends, but fundamentally the future of energy and the solution to the grid and the transition to clean energy future is interactive. And so enabling households, organizations, and the grid to actually interact and trade in real time via blockchain is the innovation here.
Great.
Thank you.
Professor Zahn, you do a lot of research in the whole compute area, and maybe share some thoughts about what you're seeing that might drive innovation.
Right. So first of all, just so excited to hear all the application scenarios from Lee's talk and all the panels talking about that. I talked to Elena yesterday, was about the blockchain. So blockchain was known as kind of like an energy-hungry business, right? So you burn a lot of energy to doing all the mining thing, and then so excited to know that blockchain can be used for sustainability as well. A lot of other exciting things. So when we do the research, what I'm seeing the two innovations or the things that the cloud business, the cloud industry could consider even more would be, number one would be the privacy and security issues. Right, so I know Google has, Amazon maybe has done this as well, and then all the industries, the cloud providers are moving towards the confidential cloud computing. So all the VMs, the virtual machines, will be in the confidential form. That means that solves the problem where, when you're using the data in the cloud, you have to decrypt it, right? So that's kind of like how do we guarantee the safety of that data while my business is moving to the cloud using the sensitive data like the house data or something like that. The other thing I think we can innovate will be the sustainability of the cloud. So the cloud computing, more businesses, more users moving to the cloud. And I think the users probably would want to know which cloud providers could offer a more sustainable way if I run the service in that. So what is the impact to my service if I run my service on Amazon or Google or Microsoft Azure? So which platform can use less energy on that or release less carbon on that? So that is sustainability might be another innovation area that the industry can do.
Great. And I thought a great wrap up after listening and getting a perspective on innovation would come from Ali and kind of pulling it all together, what we've just heard, and where Amazon's thoughts are, especially as it relates to smart cities, which can be one of the greatest opportunities for applying AI and cloud computing.
Thanks. Yeah, so I kind of talked about it in the keynote, but for us, innovation is all about just bringing out all these new services and making them more available, simpler, and easier to use for the customers, right? So all the examples we heard over here, that for us is the idea of innovating. So machine learning, when you initially used thought to be this very complex idea with which only data scientists could really tackle with, and regular developers kind of shied away from it because it was a significant effort. So one of the things missions AWS was on to say, how do we democratize these machine learning services, right? How do we make it easier for every developer, whether they build, they don't build, they code, don't code, to be able to apply these to their existing applications. So at AWS, we kind of categorize them in three different layers. The fundamental, the core layer on the bottom is where true data scientists would come in and build these algorithms and models. I guess my audio's not working.
Sure.
Yeah. That's not good at all. I'll just yell. And then the second layer is we call SageMaker, which is basically the idea that, hey, let's make it easier for developers to build their own models without having to worry about the underlying algorithms and stuff. All of that is provided. You just supply the data and build some simple models. And then above that is all the stuff I was talking about with image recognition and voice recognition, simple services where anyone can simply plug these into an API call in your application and just be able to leverage these services. You don't have to be a data scientist. You don't have to build models, algorithms, and stuff. So for us, innovation in this field is coming from our customers and all the cloud customers. But we just want to be able to provide these services and make them super easy to consume so that we hear more and more of these stories. Hope that helps.
Now let's maybe focus a little bit more on actual customers and combine customer and great outcomes. And maybe Dave Albano with some of the applications on the edge that you guys are working with would be a very good interest, especially around outcomes.
Okay. So yeah, one of our big applications that we run on our platform is for IoT, and we call it IoT Studio. And really what it is we went and interconnected with all the carriers around the world. It's basically what we're doing is an APN, if you know what that is, kind of the cellular data comes to the carrier's data center, and then it directly comes to us, right? So we program that on the SIM card that we want all that data directed to us. But what we've done is we've been able to flat rate that for our customers, right? So whether you have a Verizon SIM, an AT&T SIM, a T-Mobile SIM, right, in a device, it's all the same price, right? And we aggregate that usage across the different carriers. And so using analytics, we've been able to really simplify the deployment of IoT. And customers are putting it in everything, right? So we just signed a deal with a hand sanitizer company. They're putting plastic SIMs in all of these hand sanitizers so they can see when they need to be filled if they're online, if there's an event going on, those types of things. There's a company in Europe that uses it. So they've got these drones that actually go in the water, and they were actually originally built for garbage collection. So they have a big mouth on them, and they go in the water, and they can suck up all the garbage. But what they quickly realized is they could start sensing the water as well, right, the water quality. So it's very interesting how they've now deployed those. But for them, it's an easy way to get IoT out there, right? So whether they're in Europe, they're in Thailand, they're in South America, they're in the US, right? It's a simple way for them to deploy SIMs around the globe with one price, right, that makes it very easy to consume. And so that's been a big application for us, and we're just taking that across industry right now. We're doing all kinds of things in the buildings. So we have a big building up in Washington, D.C. We censor everything in there. There are turnstiles, there are badge readers for the gym, we get feeds off their Wi-Fi, we get feeds off their air conditioning, all of those types of things. And basically what we're doing is collecting all that information. When you walk into a conference room in their building, it will tell you the air quality in that room before you go in. It's been really interesting. It was done before COVID, but they've used it for COVID to see where people are going in the building. They use it for maintenance to see what doors, what turnstiles are getting more use. And we actually feed it to another third party, and what they do is they build a customer satisfaction rating with all of that data that says the tenants that use more of the amenities are more likely to stay within that facility, right? And so they're actually able to sense that entire building. They changed HVAC providers, which we thought was interesting. Since I had all their historical data, we decouple their data from the application. And so when they changed their HVAC provider, all we did is remap it into our system. I have all the history, and now I have all the new HVAC feeds coming in. And so they love that. There was no data conversion, right? And so we're doing all kinds of things across multiple industries.
So Tucker, now we can throw the football with better precision and train the next generation of quarterbacks. How do you talk with leagues and teams about outcomes and what centers around performance and talent scouting?
Yeah, great question. So we actually facilitated the partnership between Whoop and the NFLPA. And if you're not familiar with Whoop, it's similar to a Fitbit. It tracks sleep training or sleep recovery and strain. And every player got one in the NFL. They all wear it 24/7. And the teams have access to the data so they can see which players are sleeping properly, if they're training hard enough, and then they can use that data to determine which player should make the roster or play that day. And they also plan on leveraging that data in strategic partnerships with fantasy sports companies to kind of help analyze and help predict what a player may score in fantasy that day, or even sports betting companies. So there's certainly a lot of valuable data that can be used there. And the other company that I want to talk about that's sort of changing the landscape in sports is a company called On3 Sports. And they're building the largest database in sports history right now. So from your son's 5th grade AAU tournament all the way up to the NBA, they're going to track every single statistic. All the way from points, assists, steals, etc., to hand length, to wingspan, and they're going to use that data and run AI models to determine which statistics correlate to long-term success. They could use that data to determine if a player is a late bloomer or not. And that's also really interesting and could be very valuable to recruiters, teams, scouts. So that's definitely something to look out for as well.
Sure. And I jumped the gun a little bit because I felt like it was hard to talk about innovation without specific examples, especially if you haven't seen energy applications of blockchain before. But I will add another one in relation to electric vehicles. It's a space that is really heating up for PowerLedger around the world. And PowerLedger, in its 5 years of life, is now in 8 countries. A lot of the projects are very different and unique kind of as we scale. But EVs are a big theme because EVs are effectively batteries on wheels. And imagine what you could do with that, right? So imagine some of the conversations we're having around fleet manufacturers, large logistics, some of the projects that are just starting off that I can't necessarily talk in detail about. But what I can tell you is imagine going to an airport and knowing that you're going to be parked there for 5 days and clicking on your little app on your phone that the airports asked you to download. Yes, if the price is right, discharge my battery. I'm not going to be back for 5 days. Just, you know what, actually leave me 20% so that I can get home even if I decide to come back early. What that does for the airport is reduces their pressure on investing into more infrastructure, into more generation if they need that demand, right? You've just brought batteries to them. You might have brought batteries to your office building. You might have won some beer. So when you come back, rather than be faced with a parking ticket, you might actually be collecting some cash or some vouchers and services like the example I mentioned before, right? So really looking at EVs from that perspective and enabling vehicle to grid, vehicle to vehicle, vehicle to household trading and transmission is where we're having a lot of kind of new examples come online. And it's really important in what that is doing to the business case. We're talking with a large fleet operator who right now has estimated their payback for going to full electric vehicle fleet to be 15 years. We will be able to bring that down to 10, which is the number that they needed, via these kinds of things, right? So how can these solutions kind of really transform the business case is the big interest and a lot of application in that now for us.
David, in the energy space, I think some of the outcomes are obvious, but maybe give us some idea of what's really motivating today.
Yeah, thanks. And what Elena was talking about is very much related to what we're seeing. So as the grids become more heavily populated with renewable resources, the variability on the grid, the volatility of changing demand and supply and prices on the grid and the prices of energy fluctuates more frequently, and that's creating both opportunities and challenges. So particularly these days, since natural gas generators or turbines are the swing factor as the wind picks up, drops down, cloud cover comes in, the natural gas generators have to ramp up and ramp down more and more frequently than they ever have before. And this is a big challenge because there's not only costs associated with that, they also have, once they stop, mandatorily for environmental compliance, they need to cool down for at least 30 minutes, sometimes more. So they could be locked out of a period of time where prices spike up again on the energy markets. And what we've built is a system that anticipates those price spikes. So we help, amongst other people, the natural gas generators to survive more effectively in more turbulent times. And as a rough metric, for every 100 megawatts of generation capacity that you're running, our system can add $1 million a year to your bottom line. And doing that without any capital expenditure is obviously very interesting. But the same idea could apply to peer-to-peer trading that Elena's been talking about. You know, if you have a battery, whether it's a big utility scale battery or a home battery, it's great to be able to generate some revenue from it or exchange with other people. But imagine if you could add the intelligence of knowing ahead of time, well, should I do this now or should I do it 2 hours from now or in the next 10 minutes? and having a system that takes care of that. So those are, those are potentially huge benefits in optimizing the use of assets, lengthening their life, and increasing the value of those assets.
And maybe just to kind of wrap up, and then we'll open it up to a few questions. Professor Zhang, you've done some work around the resources and maybe some of the inefficiencies around AI and cloud computing from a cost and compute resource standpoint. Some thoughts about what we need to be aware of?
Yes, so I would like to share, one report recently released about the State of the Cloud Report 2021 released by Flexa. They did a survey about for like 750 companies. So among the 750 companies, and 85% spent $1 million in the cloud in 2020. And they also did the survey about what do you think about the cost, right, for the money you spend on that. So on average, 24% overspent on their original cloud budget. So the top two initiatives from most of the companies are, number one, moving more services to the cloud. Number two would be how do you reduce the cost, because they are 24% over budget, right? Then the other study we did, just like on the Microsoft Azure team, they released 235 gigabytes of data for the cloud users. We just published the paper, just accepted last week. And then we analyzed 2.7 million VMs created by over 6,000 users. And then we found the utilization was pretty low, actually. And the majority of the VMs utilization is less than 20%. And then many of them actually less than 8%. So that means a lot of users, and then they're using the cloud, but they do not have the knowledge or expertise to reduce the cost in that. So I think there's a lot of room on that, because if essentially for the business, right? If you want to move things to the cloud, you want to save costs. But if you over budget on cloud, if you don't know how to do that, I'm thinking because a lot of new businesses, because of the pandemic, a lot of new business, small businesses, and then they are moving to the cloud, but they don't have the expertise. They don't have a cloud team like Google or Amazon, this kind of expertise. So they move that to the cloud just by guessing. And then I think if the industry, right, so Microsoft did that, if Google can do that, if Amazon can do that, release the report, release the real users, right, cloud users on your cloud, and then the researchers can take that and then for analysis and do that. The other thing I found that will be very useful for the users is they got all the cloud providers, they have the dashboard to help the users understand their utilization, the room for optimization. What they got is individual point. For example, if I'm the user, I'm one company, I'm over there, I know my utilization, but I don't know compared with thousands of VMs, millions of VMs and thousands of other users, what is my utilization, right? Like my case, they're taking the STAR test, right? So they have the math, right? The math will tell you the percentage, right? Compared with all the kids who actually take the math tests, where are you? Are you 90% of the kids, they have higher score than you or lower score than you? So I have a comparable idea about my usage and my utilization compared with other users. So that we can really take advantage of the big data analysis if we can get the data from the cloud providers about that and do the research. I understand some of the data may be kind of like privacy issues, other issues, but Microsoft shows that the Azure team, they show that they can make that anonymous, right? The researchers can analyze the report on that. But even Amazon or Google, they can do that internally if they can release a report every year, just for all the cloud users in Amazon or in Google. So what is the average utilization of that? So where are you in terms of your business or something like that? In our paper, we actually developed a machine learning model. From all these 2.7 million VMs, we can identify which VM is less efficient. So we can even send some recommendation to the user, because each VM created by user, we know who is that. So we can basically provide some recommendations saying, hey, you're actually not using the cloud resources very efficiently. Maybe you want to switch to a lower configuration of your VM using less number of virtual CPUs and then less number of memory. So that way, we can help the small businesses, especially newcomers with in the cloud without expertise, they can reduce their costs. Overall, for the environment, right? So if we can reduce the cost for each individual user, each individual business, we help them reduce their cost. Overall, we help reduce a lot of CO2 emissions, for all the cloud services we provide.
Ali, any closing thoughts, given you're certainly one of the largest cloud providers?
Yeah, I'll talk to Andy about that. No, I'm just kidding. No, it's definitely a valid concern. I think you're right. A lot of things you pointed out are significant. I can speak from an AWS perspective. We try to really help customers manage their costs as best as we can. There's a couple of things. So I mentioned earlier, anytime AWS recognizes economies of scale and we get some sort of savings, we pass that back to the customer. So we've done proactively about 107 price reductions for different services. But then on top of that, I think just moving your application to the cloud alone is not enough. Just like Dr. Zhang said, you need to continue to optimize it, right? You need to take your application, optimize it, tweak it, apply the right services, apply the right monitoring services to make sure you can see where the peaks are taking place, what utilization looks like. So that does take a little bit of training, right? And I think you're right. I think there's a lot of skill gap that still exists. So I think there's a lot of training that still needs to happen. We actually have a service called cost anomaly detection. So what that does is it'll kind of monitor your bill, and if it predicts or if it sees some sort of a major anomaly that's happened or is coming, it'll alert you proactively. So you can go in and understand what's causing this, how can I fix it, and and that's where the consultation comes in, working closely with your cloud partners. So I think you're right. I think it's a problem. I think we're on this mission together. I think collaboration is important. It's important for partners and customers to work with the cloud vendors to understand how do we solve this, how do we address this before it takes place.
Great. I know we're butting up against the lunch hour. Any pressing questions for the panel?
Great panel. Thank you for being here today. I just want to maybe make a point on what Dr. Tsang was sharing and kind of monetize that. So the energy electricity market in the U.S. is roughly $350 billion. So is it fair to say that that maybe the inefficiencies of these VMs in the cloud could be something around 10%? Is that a kind of like a good judgment number? Not exactly, but.
Yeah, I don't know about exactly the total number about that, but the report said about, self-estimation, the 750 companies, they estimate like 30% of the VMs they paid on the cloud service was wasted. And then we did our analysis about 2.7 million VMs on Azure, and we found that the percentage-wise, like over 60% of the VMs are less efficient on that. So that means they have room to tune down their configuration on the VMs. So we don't have the total number on that, but we can just I can just tell you that.
But let's play numbers for a moment. I mean, just to think about the impact, right? Let's say it's 10%. So and let's say that not the whole world runs on cloud, but on the electricity side, right? But it's significant. Data centers represent, the last time I checked, roughly the equivalent of the consumption of energy of Tennessee, Kentucky, and Alabama combined, which is probably about, let's say, 20% of the total consumption of energy in the U.S. And so that would be $70 billion. So if 10% of that, the numbers add up, right? I mean, so again, as we're trying to reduce carbon footprint and efficiency, everything helps, right? So now, piggyback on that, thinking about the monetization of the innovation, what in particular blockchain, AI, and cloud, you're creating jobs. There's the next trend, digitalization. You're driving all this thing. What is your thought of how much better and how much bigger can it be? We have been talking about digitizing all these industries. Are we scratching the surface as we go from 10 billion devices to 300 billion devices to digitizing it? So for example, for Ali, you have, I don't know how many data centers in the world, let's say 100. Are you going to have 10,000 data centers? How big is this going to get as the data sets are going to grow? Where is this going? How big is it going to be from any of you? How big is it going to be?
I don't know. For us, I mean, everything, like we have leadership principles, right? So everything for AWS, I can speak to AWS, is focus from the customer back, right? So I think the customer will help dictate how big or small this is going to be. So if more customers demand more workloads, if they demand more cloud deployments and stuff, then yeah, I think it'll continue to grow. If at some point customers say, I don't get value from this, then yeah, I think it'll stop. So I can't look in the future, but I do think we're scratching the surface on just cloud computing in general, right? I mean, there's still, I don't know the numbers, but there's still a big chunk of enterprises that are still not in any cloud. So even though all the cloud companies are big, they're still at the early stages, right? And that's why we have the skill issue you talked about. There's still a lot of people out there that are still at the cloud 101 stage. So I think we still are on the on-ramp. We're still all going to go into cloud adoption, acceptance, and learning and stuff. There will be an inflection point, I'm guessing, but I think the customer is going to dictate for us when that happens, if that happens, and do we just continue going up? Do we go down? Yeah, for us, it's going to be all customer driven.
I'll probably, go ahead.
I'm sorry, go ahead.
I'll give a two-part answer to how big it might get. From PowerLedger's perspective, we signed on to the UN Global Compact, in part to firstly try to figure out how to make blockchain greener. So just 2 months ago, we switched from Ethereum to Solana because it's a lot more energy efficient, and that allows us to do, via smart contract, up to 50,000 transactions per second. So we are beefing up to go there, but the other part of the answer is, let's just look at RECs. RECs is the new offsetting. And right now, if you're buying your RECs, which are renewable energy certificates, which is the environmental commodity of green energy, right? If you're buying that with a broker, you're probably paying another 5 to 7% of your budget. Through blockchain interactions, you remove that, so you get that saving. On top of that, the market is pushing for what they're calling hourly RECs, right? So that your REC is actually matched to the load and the location, so that to offset Austin emissions, you're not buying RECs from Zimbabwe, right? Because then the renewable energy will go there. Once those things are clicking into place, we actually need to get to embodied energy, right? So we're still talking operational, but the embodied energy in this microphone and this fabric, all of that will be much easier offset and reduced. And we haven't even gone there. And that's a whole other universe that's around the corner.
I would like to add one point, which is like, don't think about the growth bigger very aggressively, because I see the easiest way you grow is to buy more computers, right? If you buy a lot of more computers, expand your cloud, your data center, by 20%, 50%, but the utilization is really low, then actually you're wasting a lot, hardware-wise, energy-wise. I see a lot of opportunities. Software can play a very important role. For example, last year we did a paper on Alibaba. They released the data set, so we analyzed the Alibaba data set on that. So by just co-scheduling the batch jobs with the service jobs, kind of like the service jobs is kind of like you buy things from Amazon. Alibaba is very similar to Amazon. So you buy things from there, you want that sensitive, right? When I want to make a transaction, I want to pay Amazon, you don't want to delay that, right? That's the service jobs. That's very delay sensitive. Also, you run the batch jobs, which are less delay sensitive. For example, when you buy this book, Amazon will tell you the people who buy this book also buy that book, right? That kind of data mining algorithm, the batch algorithm, that's delay insensitive, right? So you can run that a little bit late or something like that, can be interrupted a little bit. So by co-scheduling these two jobs into one system, and then they can significantly increase the utilization rate of the server. So I'm thinking the AI, right? So the AI workloads is going to be a big portion. It's going to reshape the workloads running in the cloud, I'm thinking. So right now, my limited knowledge about the AI workloads is that we don't have a very clear understanding about AI, because AI changing so fast, so quickly. I'm keeping up every day trying to with the changes on that. So if we could understand the AI workloads even better, and then those AI workloads are usually running for hours and days of training, right? Their utilization is high, and then they could be co-scheduled with the service jobs or like the low utilization VMs together or something like that, if we could do that. So basically, what I suggested would be, before you expand your data center, buy more software, explore the software solution to improve efficiency, reduce the cost. Maybe there's a lot of room there.
Another question from the audience before break? All right. Well, I want to thank our panelists and our keynote speaker, and I'll ask Andres to guide us through to the lunch program.
Thank you, everybody. And hopefully.